Hello everyone. So in this lecture we will be discussing about instruction set and addressing modes. Now at first we need to understand what is an instruction set. Now before getting into instruction set we must understand what is an instruction. So an instruction is basically a command to the microprocessor to perform a given task on specified data. It may include 8-bit or 16-bit data and internal register, a memory location, and so on. The entire group of instruction supported by a particular microprocessor is called an instruction set. So it depends from microprocessor to microprocessor the set of the instruction it supports. Now within an instruction we can have two parts. The first part is known as the opcode and the second part is known as the operand. Right. So the first part is the opcode and the second part is the operand. Now what is opcode? Opcode is a part of the instruction that tells the microprocessor what should be done. And operand is the part of the instruction that contains the data to be acted on or the memory location of the data in a register. Now, why I am taking the example or the reference of a microprocessor, it's because it will be easier for you to understand. Now, in case of 8085, we know that the memory is divided into blocks. Each block can have maximum of 8 bits of data. That means 1 byte of data. And each memory location has a particular address. And the size of each address is 16 bits or basically 2 bytes. Now come back to one word, two word and three word instruction. When we want to refer some memory address, then we usually consider 3 word or 3 byte instruction. Say for example JMP 2050H. So this JMP is an opcode that will consider 1 byte. This 20 is an hexadecimal value, so each hexadecimal value takes 4 bits and 2 hexadecimal value therefore will take 8 bits, which is 1 byte. So this 2 hexadecimal value will take 1 byte and the other 2 will take 1 byte. So this is an example of 3 word or 3 byte instruction. Now if we consider MVI A, 20H, this basically means move the data 20H to the register A, which is the accumulator. Now this is an opcode and this opcode will basically occupy 1 byte of memory and this 20 will again occupy 1 byte of memory. So this is an example of 2 word or 2 byte instruction. Now there are also some instruction that takes just 1 byte in 8085. Say for example add B. This basically means the accumulator has some data. You have to perform addition of accumulator and the register B, the content of accumulator and the content of register B, and keep the data in the accumulator register itself. So this is the difference between 1, 2 and 3 word or 3 byte instruction. Okay, so let us now start discussing the addressing modes. So we have 5 different types of addressing mode: immediate, direct, indirect, register and register indirect. So I'll be explaining you each one of them using this diagram. So on the left side here you can see the instruction, and let's say this is the memory. Now in case of immediate address, the operand is present here only in the instruction. So you have the opcode over here, and the operand is present within the instruction itself. So in this type of instructions are known as immediate instructions. Now let us go to the next type. Now in direct addressing, what we have here, we have the opcode, and here we have the address. Now whose address we will be having? We will be having the address of a memory location where the operand will be present, right? So in direct addressing, we have the address within the instruction, which is the address of a memory location where we can find the operand. Now let's go to the third one. In indirect addressing mode, we have so in indirect addressing mode, we have the address of a memory location that holds the address of another memory location where the operand is present, right? So it holds the address, right? So that is why it is known as indirect addressing mode, where the instruction holds the address of a memory location, which again holds the address of the location where the actual operand is present. So to move further with the last two addressing modes, I have added another block, that is the register block. It is basically the set of registers present within the microprocessor. Now, register addressing mode, we have the register within the instruction. Now, actually, the name of the register within the instruction, right? Obviously, we won't be able to have register within the instruction. So, the instruction will specify the name of the register that contains the operand, right? So, it holds the name of the register that contains the operand. Fine. Now the last one, that is register indirect. Here again the instruction refers an register, but in this case register holds the address of a memory location which holds the operand, right? So in the last one, in last addressing mode, that is the register indirect, here instruction holds the name of the register which contains the address of a particular memory location where the operand can be obtained. So hope you have understood each and every concept. So let's summarize. The instruction set, we have understood that it consists of two parts, the opcode and operand. We have understood the classification of instruction based on word size. There can be three types. And we have understood the different addressing modes, how an instruction can refer to an operand. So hope you have understood each one of them. Thank you.